Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode, we're gonna take a closer look at display technology relating to mobile phones. So let's dive right into it. Now, first thing you have to understand, it's very crucial. It is our planet's biggest input and output device. Generally, it's output because your computer is generally not touch screen, but that's the whole point. If you guys remember old phones, the screen was a small part, buttons were used to be the big thing. As you see now, phone is mostly screen. We are trying to achieve 98% screen to body ratio, so let's just say it's a big deal. So let's take a closer look at LCD. This is the baseline technology of almost 98% of mobile industry. So what the heck it is basically a fancy way to blocking light. That's all there is to it. So what do we generally do? We have a light source, either be LED, either be emissive panels, whatever you have. You simply have a light source. Light comes in, then you apply a polarizer to it. So basically you are stabilizing the light. You're like, okay, calm down, stabilizing that. After that, you go through what we call LCD. Now this LCD is there are many technologies into this, but I will try to give you a basic idea. Because the light is polarized, you have you force that light to go through what we call gate transistors, basically thin film transistor. You always hear TFT. That's what we are forcing it to go away from, go into. Now this is basically like a valve. You open it or you close it. Now if the valve is open, the whole light goes through. If valve is closed, it does not go through. That's all that is happening. How that valve is opening and closing, that's basically it's not becoming opaque or transparent. It's changing the polarity. So that's why we need polarized light. It will not work with normal light. So once you polarize it, light is whether it's like on or off, then it goes through what we call color filter, RGB color filter. Then you go through force it to another basically polarizer, and then to your final screen. So lot of steps, but this is very simple. Like in terms of what we need to do, it's very simple. And nowadays this whole how many things we need to have is shrunk down to very large extent. That's the whole idea of IPS. You may heard all new mobile phones have IPS, basically in panel switching. So all this complex electronics is shrunk. Earlier used to have 10 to 12 layers to make an LCD, like in terms of substrates and mechanical structures. Now we can do that in 5 to 6. So that is your IPS. Is also better simply because it will allow you to have a phone that you can look from multiple angles. Basically, if you remember old days, if you have mobile phone like this is the screen, you look it straight out, awesome. You go it start to look like negative. That used to be the consequence of this TFT. With LCD, with IPS, we remove that consequence. Now you can go almost 180-degree visibility is there. Now IPS is kind of old technology at this point, and newer mobile phones, be it Motorola, the phone that I recommended in last one, generally have LTPS, basically low temperature polysilicon. What does that do? Do not think too much about it. Basically it refines IPS using a different material. Basically it's inherently IPS itself is just they change the material to it, basically going from let's say steel to aluminum. It's like that. They change the material. It allows them to have higher pixel density, better response time, and better energy management. So all LCDs are more or less the same. It's just the quality of the LCDs depends on the technology. If you have TFT LCD, very cheap mobile phone, not very good. IPS, very good. IPS to LTPS is now the leading edge technology that can compete almost with the same level to AMOLED. Now be mindful, we always have a light source in the background. Now we come to the king of all current mobile display, AMOLED technology. Now if you ever heard the saying fortune favors the bold, this is the story of Samsung. Basically AMOLED stands for active matrix. Basically the wiring is on the one side rather than on both sides. It's on one end. Organic light emitting diode, basically it's LED. So many of you have seen the billboard of this nature where you have LEDs, RGB LED, and they have a display. But problem with this is that the RGB LED itself is very big. You can't miniaturize that. So somebody came up with the idea, let's put monochromatic LEDs, basically red LED, green LED, and blue LED, rather than trying to make one LED that gives on all three. Then we can miniaturize it. So tada, that's AMOLED. Basically it's LED itself. There is no backlight. That's the core difference between this. This now can reduce the overall construction to 3 substrates. That's how small we can make it. Very thin, very flexible, Like this is the cutting edge technology. It is very like efficient also in terms of power uses, because if you are familiar with the whole idea of always on display where you have like notification going on, things of that nature, this can do that. Because why? Because the places that are off, basically they're supposed to show black, goes off, like they're off, like they're not doing anything, there is no backlit there, it's off. So if you can compare the power uses of AMOLED display versus a LCD display, AMOLED is upwards of 10 to 15% more efficient. Like that's the final one. Generally in principle it's supposed to be 30% more efficient, but by the time you have all the other electronic things or another hoo-ha, it always ends up less efficient. So but it is 10 to 20% more efficient, which is significant. And in terms of this also, because you are getting black, which is absolutely black, there is no light coming out, there is no light leakage, it achieves what we call very high contrast ratio. So these are the main things, LCD and AMOLED. Now we talk about the future of this technology. Now if you have LCD, you still may have issues with we call image persistence. Basically, if you change the background, let's say you are using WhatsApp for a very long time, and then you switch to, then you realize the WhatsApp is still there, but you will be like, how the heck that's there, even though my mobile has LCD. It's what we call image persistent. Now it's thankfully it's a very transient thing. Basically it will disappear in 20 minutes. Basically that gate that was polarizing the light, it kind of got stuck. So over few seconds it may go away, as long as 10 minutes is the worst case scenario. So image retention can happen in LCD also. So do not think like, oh, I have LCD, I do not have any screen issues. You can have very easily issues. Now burn-in is a very very talked about topic with AMOLED technology, is that where the pixels itself get damaged. Now when I talk about image persistent, it damages my experience, but it does not damage the panel itself. Panel will retain, panel will take the damage, and over time it will heal itself. In AMOLED, because the organic part of it, the fact that it is basically LED, every LED decays over time. Red one can last for practically forever, the green one little bit less, blue one almost dies quickly. So if you made torches from that, those LEDs, the blue one will only last for 5,000 hours, green one will 10,000 hours, red one will 20,000 hours. Now this creates a problem. The color drifts because your blue would be used more, and not to mention, while you are using blue with more images and all that, you're also degrading it, so the blue color shifts. So Samsung played a gamble with AMOLED technology, is that they knew for a fact that nobody is going to use their flagship for more than, let's say, 2 to 3 years. So they put the technology and they made sure it's good enough for 3. And AMOLED right now, unless you have some very bad luck or your batch is very bad, you will never have to practically worry about this sort of thing where your screen is permanently damaged. This is different from image persistent, which will happen in LCD screens, but it's a temporary thing. It will like ghost your screen with whatever you had last, but this is temporary, this is permanent. This will be fixed. In the future, this will be fixed. Now, how do I know? Because LED TVs basically that rely on AMOLED technology, they have been working for 5 to 8 years at this point in time, and they haven't shown no signs of degradation. The quality of the panel is directly dependent on the money we spend, basically the quality of material. So as mobile phones get more and more expensive, and as basically developers or whoever is manufacturing the display, basically Korea, they become more and more refined in their production technology, the AMOLED burning will be a thing of the past, and LCD is also improving. Then this idea of ghosting or things of that nature will also become thing of the past. You will no longer have to worry about these things in the future. Then flexible display. Now you might be like, okay, I don't like this sort of folding phones of that nature. Flexible display is still important to you, because this will make sure if your phone falls, the screen survives. Like screen cracking, generally we want to compromise something. We do not want to make something flexible simply because LCD is inherently inflexible. Now once you go to AMOLED, it becomes flexible. So instead of having a Gorilla Glass that will stand the frustration and shockups and then shatter with the when it exceeds its physical limitations, your flexible display will absorb much more impact. So basically you will have much more resilient mobile phone. That's why flexible display is important, even if you simply buy a brick phone. Then HDR, we're not gonna go for 4K in mobile phones simply because Sony has already done that. 4K mobile phone is available, you can buy it also, but it's impractical simply because the screen display becomes so tiny, like your eye cannot travel far enough to actually absorb the details. The pixel per inch can go as high as to 800 to 1000 dpi. That's so damn high, you can't perceive the information. That's you have to literally go very close and you can't perceive it. And whenever you talk hear things about retina display, things of that nature, whenever somebody is giving something fancy name, that means they haven't invented it. If they are giving a official name like OLED, which is from LG, and AMOLED, which is from Samsung, that means these are patents. So whenever Apple says retina display, it's nothing fancy, it's just they are renaming something old. That's why they cannot tangibly qualify that name. So that's what we are gonna achieve in the future. No more screen burning, no more ghosting, flexible things. That means your screen will last longer if it falls. And then HDR, this is the next big thing, because basically as of now Amazon Prime and Netflix both support HDR, and they can push HDR to your mobile phone. Condition applied, only certain mobile phones can receive this content. It's basically software locked right now. So if you have Samsung Galaxy Note 9, you can watch it, and if you have iPhone X, you can watch it, because those screens are validated for HDR. So then when you are using your Netflix account through that, it will detect it and then it will give you HDR content. Now, does that make a day and night difference? To some contents, yes, especially the content if is shot in dark, it will make very clear advantage that you are watching it compared to like very cheap mobile phone versus a very expensive mobile phone. So these are the three core things that you're gonna see in the future. So this was my presentation on display technologies. I hope you liked it or learned from it. In that case, please leave a like. If you didn't, don't worry about it. You can dislike it twice. I would urge you to leave a comment as I reply to all of them. Please subscribe, press the bell icon if you're free, and as always, thanks for watching.